Welcome to A-Star Science. Today we're going to look at the AQA GCSE Combined Science Paper 1 for Chemistry from the May 2023 series. This is a higher tier paper. Let's jump right in. The first question says, this question is about carbon dioxide. Carbon dioxide is soluble in water and forms an acidic solution. So we can see here it talks about an acidic solution. It says, which ion makes a solution acidic? Well, we know, for example, in acids always have an H plus ion. Okay, so that's a hydrogen ion. For example, you can see here HCl, there's the H plus ion. So your answer would be an H plus ion, a hydrogen ion. What makes it an ion, we need to remember, is that it has the plus sign. Okay, so that makes it an ion. So you need to put that into your answer. It says, name an indicator that could be used to test if the solution is acidic. Well, typical indicator could be universal indicator. That's an easy one to remember, universal indicator. And the universal indicator, remember, is the one that turns multiple colors. And if it was acidic, we would expect it to be red. You could also put orange or even yellow. Remember, if it was alkaline or basic, it would be blue or purple. But in this case, you would put universal indicator, which would be red, orange, or yellow. Of course, you could also use litmus paper, and that would have to be blue litmus, which would then turn to a red color if it was acidic. Let's go to the next page. So here it says figure 1 shows the mass of carbon dioxide that would dissolve in 1 dm cube, decimeter cube of water at different temperatures. How does the solubility of carbon dioxide change as the temperature of the water increases? So we can see as the temperature of the water increases this way, the solubility of the amount of carbon dioxide goes down. So the higher the temperature, the less carbon dioxide is able to be dissolved into that water. So that will be this answer here. It says carbon dioxide dissolves in water to form an acidic solution. How does the pH of the solution change as the temperature of the water increases? So if we go back to the answer, if we say that the carbon dioxide is going down as the temperature goes up over here, that means there's going to be less carbon dioxide as the temperature gets hotter. That means the pH should also increase. The pH should increase because there's less carbon dioxide. It says carbon dioxide dissolves in water to form an acidic solution. So if the carbon dioxide is going down, that means that it's going to be less acidic. That means the pH of the solution increases. Why do we say that? Remember that pH scale goes from 1, 7 all the way up to 14. This side is acid side. This is the alkaline side, or the base side. So the pH is going to increase because it becomes less acidic. Calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. The equation for the reaction is calcium carbonate plus 2 moles of hydrochloric acid yields calcium chloride plus carbon dioxide plus water. What is the state symbol X in this equation? Well, in this equation, here's the state symbol. It could either be aqueous, gas, liquid, or solid. And we know that here is going to be a liquid. So the state symbol is going to be L for liquid. Figure 2 shows the equipment a student used for this investigation. So that's just a picture of the equipment. So we know that this is a measuring cylinder. And that's used to measure volumes accurately. This is a conical flask. This is a balance, digital balance, weighing scale, and that one's labeled as a gas syringe. It says the student investigated the volume of carbon dioxide produced when different masses of calcium carbonate reacted with hydrochloric acid. Describe a method that the student could use. Okay, so we want to look and see that the independent variable here is the different masses of calcium carbonate. So the independent variable is the masses of calcium carbonate. And the dependent variable, which is the one that we're going to measure, is the volume of carbon dioxide formed, how much gas is formed. Okay, and we're going to need the gas syringe for that. And for the masses, we're going to need the balance to measure that. And what are we going to keep the same? The control variable. Well, that has to be the hydrochloric acid, which we don't want to change. So that's going to be the volume of hydrochloric acid, aqueous. So we need to suggest a method. So step 1 would be, you can just come up with an arbitrary value where to start with the hydrochloric acid. So let's say we start with 25 milliliters of hydrochloric acid into the conical flask. And then you need to measure that. So we're going to say 25 mils up into the conical flask by using the measuring cylinder. We run out of space. Step 2, we're going to measure out. Let's just start with 5 grams of calcium carbonate. We're going to measure calcium carbonate by using the balance. Step 3, we're going to add the 5 grams of calcium carbonate to the HCl, the hydrochloric acid, in the conical flask. And immediately attach. Let's say attach, not put. Let's say attach the gas syringe to capture the carbon dioxide released. Step 4, we can do that until the carbon dioxide, the calcium carbonate runs out. Okay, we can do that till the calcium carbonate runs out, because they wanted to investigate the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. So step 4, allow all of calcium carbonate to react. And then measure amount CO2 from the gas syringe or in the gas syringe. Okay, and then step 5, we're going to repeat steps 1 to 4 with different masses of calcium carbonate. So we're going to repeat that with different masses of calcium carbonate, and we could suggest in 5-gram intervals. So adding 5 grams at a time. Okay, so that's the basic idea that we would use. So we need to make sure that we remember that the hydrochloric acid is actually going to be the limiting reagent after some point because you're going to keep adding the calcium carbonate as you go. And this should get you a good amount of marks. The key is to remember your independent variable. You're going to measure that using a balance, the masses of calcium carbonate. The dependent variable is the volume of carbon dioxide, and the control variable is the volume of hydrochloric acid. We need to keep that the same. Okay, good. So that will get us about 5 to 6 marks. Let's move on to question 2. Lithium hydroxide reacts with sulfuric acid to produce lithium sulfate. Here's the equation for the reaction. So we have a hydroxide plus a sulfuric acid. Hydroxides are bases. And obviously I just said this is an acid. So an acid plus a base is going to give a neutralization reaction. That is a neutralization reaction, acid plus base. Give the relative formula mass of the sulfuric acid. So how do we do that? Well, here's the formula. So you take the atomic masses, which they give you here. There are 2 hydrogen, and each hydrogen is worth 1. So that's 1 times 2, plus sulfur, which is worth 32, plus oxygen, 16 times 4. Okay, so let's just work that out very quickly. You're going to use your calculator. So 2 plus 32 plus 16 times 4, which would be 98. Okay, so that would be 98 as the relative formula mass of the sulfuric acid. Calculate the percentage by mass in the lithium sulfate. So it tells you that they want a percentage of mass of oxygen, which they give here already. So they've made it quite easy for you. So the percentage by mass formula is the mass of substance over the total mass. So in this case, the mass of substance that we're looking for is oxygen, which is 16 times 4, because here's the oxygen here, 16 times 4, divided by the total mass, which they give, which is 110. So 16 times 4 is 64 over 110. And you're going to multiply that by 100. So 16 times 4 is 64 divided by 110, multiplied by 100. Let's look on a calculator. And that is 58.18. Now, if we look here, the smallest amount of significant figures here is 16. So we're going to round that back down to 58%. And that would be the answer. 58%. In fact, it says 2 significant figures in the answer is asking. Calculate the concentration of lithium sulfate in grams per decimeter cubes. Well, concentration is equal to mass over volume. And that's what the units tell us here, mass over volume. And so the mass is 0.30 grams. And the volume is 25 centimeter cubes. But they want it in decimeter cubes. So I must divide by 1,000. Okay. To get to decimeter cubes, you must divide by 1,000. So it's 0.3. That would now equal 0.30 grams over 0.025 decimeter cubes. If you put that in on the calculator, that is 12 grams per decimeter cube. That's how you do concentration. Concentration can also equal moles per volume, but in this case, they're asking us for the, they give us the mass. They want the concentration in grams per decimeter cube. Good, on to the next question. Sodium is in group 1 of the periodic table. Sodium reacts with oxygen to produce sodium oxide. So first we see that there is a 2 here, so I need to put a 2 over here to give that oxygen 2. That now makes that sodium 4, so I'm going to put a 4 there. Simple to balance that like that. Now, explain what happens to sodium atoms and to oxygen atoms when sodium reacts with oxygen to produce sodium oxide. This is a 4-mark question. So in order to do that, we need to say what happens to the sodium atoms first. So let's just think about this. Sodium is in group 1, like that. And oxygen is in group 6. So it's going to have 6 electrons. And so we're actually going to need another sodium, which both are going to give up their electrons like that. Hence why it's Na2O. So what happens in terms of the electron? You want to say that for the sodium, each sodium atom gives an electron to the oxygen. And when I said each, I should have said 2. And we want to say what it becomes. So when the sodium gives the electron to the oxygen, it's going to form a 1 plus sodium ion. Okay, because it's going to lose those electrons to that oxygen and become positive. So this is actually going to be worth 1 mark here. And then this part here, talking about an ion, is going to form the other mark. So here now, we're going to talk about the oxygen. Each, or in this case, we don't need to say each because it's only 1. We're going to say the oxygen atom gains 2 electrons to become a 2 minus ion. Okay, 2 minus ion. So that is going to give us our 4 marks I do need to say here, though, I should say each sodium atom. I should have said 2 sodium atoms gives, or we could use a better term, would be loses an electron to the oxygen to form a 1 plus sodium ion. Okay. On to the next question. Sodium burns in a gas jar of oxygen. Figure 3 shows the apparatus. So here's the sodium burning in oxygen. Give 2 observations seen during this reaction. Well, this is going to be a very vigorous reaction, and we know sodium is going to burn, so that means it's going to give off a flame, okay? And the flame color will be yellow, so a yellow flame. So if now the sodium reacts with oxygen, it's going to form the sodium oxide that we just talked about, and this is going to be a white powder. Remember, it says 2 observations, what you would see. So you want to say you will form a white powder. Okay, you would also see white smoke, which is what we eventually go to a white powder. So we don't need this part here. We want to say white smoke or white powder. 2 observations. Describe 2 differences in the observations if potassium is used. Well, potassium is much more reactive, so that's going to burn faster. Okay, and potassium is going to have a different color. If you remember flame tests, potassium is going to burn with a lilac flame rather than an orange flame. Good. Group 7 elements are known as the halogens. All atoms of group 7 elements contain protons, neutrons, and electrons. While the earliest particle that was found was the electron. Okay, so it could either be any of these 2 answers. And a good way to remember this is that the neutron, because it was neutral, was the hardest one to find. So this is the order that it's going to go in. And so it was that one. The electron was found first, followed by the proton, then followed by the discovery of the neutron. Table 1 shows the mass of a proton and an electron. Calculate how many times heavier a proton is than an electron. Well, you just want to divide that. 1.673 times 10 to the 27. And you want to divide that by the electron, 9.109 times 10 to the minus 31 to find out how many times heavier that is. Okay, so you need to put that in on the calculator. Let's do that now. So that is 1837.645076. That's quite a long answer. But if we look here, you can see both of these are to 4 significant figures. So we just need to put the 1837 as our answer. A bromine atom can be represented as 81 over 35 bromine, Br. So this is our atomic mass. This is our atomic number, or our proton number. It says, what's the number of neutrons? Well, we know we can do the atomic mass minus the atomic number to tell us the number of neutrons. And so that's going to be 81 minus 35, which is going to equal 46. 46 neutrons. It says, what's the number of electrons? Well, the electrons equal the protons. And the protons are from the atomic number. So that means that's going to be 35. But it says here in a bromide ion. So that's a bit of a trick question. So bromide ion, that means it's going to gain an electron plus 1. So it's going to be 36. That's really tricky of them to put that in. Okay. So it's going to gain an electron because bromine is in group 6. So that means, group 7. So that means it's going to be a -1 ion. It's going to gain 1 electron. So that is the correct answer, 36. Need to be really careful for those types of questions. Chlorine has 2 isotopes. Table 2 shows the percentage abundance of the 2 isotopes. So they want you to calculate the relative atomic mass. The way you do that is you take the percentage abundance of each isotope times the mass, and you add it to any others that are there. And you do that and divide by 100. So in this case, we see chlorine is one isotope is 75.77. That's there. Times the mass, which is here, 35. Plus the other isotope, which is 24.23 times 37. And we're going to do that and divide by 100. So we're going to do that and divide by 100. They wanted to 2 decimal places. Well, the actual answer is 35.5. We're going to round that up here, and that is going to be 36. Oh, sorry, incorrect. They wanted to 2 decimal places. So to 2 decimal places, I need to go back on the calculator, which is 35.48. That would be 35.48 on the calculator. 2 decimal places. Figure 4 shows the outer shells in the molecule of chlorine. Complete the dot and cross diagram. Well, we know chlorine is in group 7. So this one is going to have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And so will this one. 1, 2, 3, 4, 5, 6, 7. And that will be the dot and cross diagram for chlorine. Remember, it's in group 7, so that means it has 7 electrons in the outer shell. Why does sodium chloride not conduct electricity? This is very important. Well, sodium chloride is a metal and nonmetal, meaning it's ionic. And so it has no delocalized electrons. And because it's solid and no mobile ions. You could really just say no charged particles, but in this case, they want you to say no mobile ions because they're talking about an ionic substance. Sodium chloride solution conducts electricity. Sodium chloride also conducts electricity when molten. Why? Because those mobile ions that we just talked about are then free to move. So molten is the same as saying it's liquid. Here's an electrolysis apparatus. It says suggest an element that could be used to make the inert electrodes. Inert means non-reactive, and of course, we're going to use graphite in that case. You could also say platinum, but that would be very expensive, so the best answer would be graphite. It says complete the half equation for the production of chlorine. Well, here is the chlorine ion or chloride ion, and it says it's going to make chlorine gas. We can see that there are two of them, so we need to put a 2 here. And here we have an ion, sorry, an electron. So here it's -1 as an ion, but over here it's 0. So how do we go from -1 to 0, or -1 to 0? We're going to lose an electron. But there are two chlorides, so we're going to lose 2 electrons. And that's done. Sodium chloride solution has a pH of 7. During the electrolysis of sodium chloride solution, hydrogen gas is produced at the negative electrode. The pH of the solution increases, meaning it gets more alkaline. We'll explain why. Well, when we look here, if we did the electrolysis and we had sodium chloride, that means we have sodium plus and chlorine minus. But it's a solution, so we also have H2O, which is water. And those two ions are H plus and OH minus. Now with the electrodes that we put in, with the anode and the cathode, we know that the most reactive one is going to stay in solution. So this case, the most reactive cation will stay in solution, and so that's going to be the sodium. That means the hydrogen will be released as hydrogen gas, and we know that the chloride is going to be released as chlorine gas. That means that left in solution is going to be the sodium hydroxide, and hydroxides are alkaline or basic. This is going to make an alkaline solution, and the pH will be 8 to 14. And that is why the pH of the solution increases. Okay, so wants to explain why. So how can we explain this in words? To explain this in words, we would say something like, the solution contains H plus, OH minus, sodium plus, and Cl minus ions. During electrolysis, the H plus forms hydrogen gas at cathode, and the Cl minus forms chlorine gas at the anode, leaving sodium and OH minus or hydroxide ions to form sodium hydroxide, which is an alkaline solution. Okay, so that's where we would get our higher pH from. Now it's good to suggest why, and we want to say that, see if we have a bit more space, that the hydrogen is less reactive than sodium. So that's why the hydrogen is released and sodium stays in solution. Sodium stays in solution, and the OH minus increases. And that's what causes it to be more alkaline. So that will definitely get you your full 4 marks. So here we go. Acids react with some metals. Metal plus acid is always a salt and hydrogen gas. So it says describe how solid magnesium chloride is obtained from the reaction mixture. So here's this reaction mixture that they reacted until excess remains. So we want to describe how the solid magnesium chloride is remained. So we would have to just filter that. Filter using filter paper and funnel. And it says from the reaction mixture. So it wants here the solid magnesium chloride. So this would remove the magnesium. To remove excess magnesium. That's step 1. And then step 2, if we want the solid magnesium chloride, then we need to evaporate to crystallize magnesium chloride salt. That's how we would get the magnesium chloride from this solution here. Explain what happens to the magnesium atoms in this reaction. Here's the reaction between magnesium and hydrochloric acid. It's a redox reaction. So let's take a look at this. The magnesium is going to react with the hydrochloric acid to form magnesium chloride. So here we can see the magnesium as an element has a charge of 0, but here the magnesium has a charge of 2+, because now it's bonded to the chlorine. So how do we go from 0 to 2+? We would have lost 2 electrons, which means that it's oxidized. Okay, so the magnesium is oxidized because 2 electrons are lost. So you write that oxidize, it's oxidized by losing 2 electrons. Remember that reduction is gain of electrons and loss of electrons is oxidation. Okay. So at the end of the exams, they always have a calculation question. So it says calculate the concentration of magnesium chloride solution. We know again concentration is mass over volume, and it gives us 0.72 grams of magnesium is added to the 100 centimeter cubes of hydrochloric acid. So we're going to have to do a bit more in this case. I'm going to rewrite out that equation. This is a 6-mark question. So we have the magnesium plus the hydrochloric acid, which is going to form the magnesium chloride plus hydrogen gas. I'm going to balance that. And that's all balanced now. So we're going to need to determine the moles in this case. So I'm going to use my table method. You can learn more about that on another video on my channel. So here we have the mass of magnesium, which is 0.72 grams here. And to find the moles, remember it's Mr. Mole mass. To find the moles, we need the mass divided by the MR. So the MR of magnesium is 24. So let's just use our calculator for that. That's going to give me 0.03 moles. And this tells us it wants the concentration of magnesium chloride. So there's a 1:1 ratio. This is how much magnesium chloride will be formed. If there's 0.03 moles here, I'm going to form 0.03 moles here of magnesium chloride. Now they want to find the mass of magnesium chloride because I need to find the concentration. Concentration is the mass over the volume. That's what they're asking us to find here. Concentration. So let's find the mass first. Mass is the MR times the mole. So magnesium chloride MR is 95. So to find the mass, I take the MR times the mole, which is 0.03. And that's going to equal 2.85 grams. I'm going to now divide that because they want the concentration by the volume. It says calculate the concentrated magnesium chloride solution produced in grams per dm cube. Well, there's 100 centimeter cube. And I need to divide that by 1,000 because we want it in dm cube. Remember here it says dm cube, but this is in cm cube. So that's why I'm going to divide that by 1,000. I'll put that into the calculator, and that equals my final answer of 28.5 grams per decimeter cube for full 6 marks. Question 7. This question about structure and properties. Which pair of substances both contain atoms in hexagonal rings? Well, we know that graphite does, but diamond doesn't. So not that one. Graphene does, and fullerenes does. So that is the correct answer there. Explain why the structure of copper allows the conduction of thermal energy. Well, here is a metal lattice. Copper will look like that. And this will be in alternating layers, like this. And these are the copper cations. They will be 2+. We'll just use plus for now. And in and amongst, you're going to have a sea of delocalized electrons. And these are free to move, but they're also free to allow for the conduction of electricity and thermal energy. So it's the delocalized electrons, okay? And they can move to transfer the heat energy through out the structure, okay, throughout the structure. Explain why copper oxide has a high melting point. Well, this is a metal and non-metal, so we know that this is ionic, and we know that ionic has strong electrostatic forces. You want full marks, you must say forces of attraction. Okay, and what gives it that? Well, we have the Cu T2 plus and the O2 minus ions, which are here. That's the strong electrostatic force of attraction between oppositely charged ions. And because they're strong, they require a lot of energy to overcome. Okay, require a lot of energy to overcome these forces. Now, why does water have a low melting point? Well, water, H2O, is covalent. That means it has weak intermolecular forces. Remember not to get them confused. It's not electrostatic, so they have weak intermolecular forces. So little energy, low energy required. To overcome. Okay, this is worth 3 marks. And they want you to talk about the fact that they are small molecules. Remember that covalent, we call them simple molecular because they're small molecules. And that will get you your 3 marks. And that was it. Good luck with passing your next GCSE Higher Paper 1 exam. Please make sure you like and subscribe and leave a comment below if there's any particular topic you'd like me to do a video on.